talk about remainder theorem. Our expectation for today's topic is to illustrate remainder theorem, rational theorem, and factor theorem. Also includes proving the use of remainder theorem, factor theorem, and rational theorem. Now let us find out what is a remainder theorem. The remainder theorem states that P of C is the remainder when the polynomial P of X is divided by X minus C. The divisor X minus C is then restated as X is equal to C. So the remainder theorem allows us to determine whether a linear expression is a factor of the polynomial expression easily. It is related to the factor theorem. It says that when you divide by or the remainder is find the remainder using the remainder theorem. So P of X is equal to x cubed plus 4x squared plus 3x minus 2 is divided by x minus 3. So this is the solution. Again, write P of X is equal to x cubed plus 4x squared plus 3x minus 2. Now replace x with positive 3. So P of 3 comes from x minus 3. So the given C for x minus 3 is equal to 3. So therefore, P of 3 is equal to 3 cubed plus 4 times 3 squared plus 3 times 3 minus 2. So replace all x with 3. Next, when we say 3 cubed, it is 27. And then 3 squared is equal to 9. And then 3 times 3 is 9 minus 2. Then simplify. Bring down 27. 4 times 9 is 36. And then 9 minus 2 is 7. When you add them, 27 plus 36 plus 7 is equal to 70. Therefore, our P of 3 is equal to 70, or the remainder is 70. Now, since there is a remainder, so therefore, x cubed plus 4x squared plus 3x minus 2 is not divisible by x minus 3. This also means that x minus 3 is not a factor of x cubed plus 4x squared plus 3x minus 2. Another example. Find the value of P of X using the remainder theorem. If P of X is equal to x raised to 4 plus 3x cubed plus 5x squared plus 5x minus 2 is divided by x plus 2. Again, you need to find the value of C. So our C is negative 2. And then replace x with negative 2. So negative 2 raised to 4 plus negative 2 raised to 3, then negative 2 raised to 2, then negative 2. Let us simplify. Negative 2 raised to 4 is 16. And then, negative 2 raised to 3 is negative 8. Negative 2 raised to 2 is 4. And then 5 times negative 2, it is negative 10 minus 2. Simplify. So bring down 16. 3 times negative 8, you have negative 24. 5 times 4, you have 20. Negative 10 minus 2 is negative 12. Then let us add 16 minus 24 plus 20 minus 12. The answer is 0. So therefore, our P of negative 2 is equal to 0. Meaning, there is no remainder. Now, since there is no remainder, x plus 2 is divisible by x raised to 4 plus 3x cubed plus 5x squared plus 5x minus 2. Let's have another example. Find the value of k when p of x is equal to 3x squared plus kx plus 4 is divided by x minus 1 and the remainder is 2. Now first, you need to solve for p of x. So p of x is equal to 3x squared plus kx plus 4. And then, since the divisor is x minus 1, therefore our c is 1. So replace all x with 1. And then simplify. So 1 squared, it is 1. So 3 times 1 is equal to 3. 1 times k is equal to k. And then bring down 4. Then add 3 plus 4 is equal to 7. So our P of 1 is equal to 7 plus k. After solving P of x, you need to solve the value for k. Now, since P of x is divided by x minus 1 and has a remainder of 2, so it goes like this. P of x is equal to P of 1 and the remainder is 2. Now, since P of 1 is 7 plus k, we can equate using 7 plus k is equal to 2. Then, transpose to the other side, 7 becomes negative. So, negative 7. So, 2 minus 7 is equal to negative 5. So, therefore, our k is negative 5. Let's have some activity. Activity number 1. Find the value of p of x for the given x using the remainder theorem. So number 1, p of x is equal to x cubed minus 4x squared plus 2x minus 6. Our x is equal to 4. Now what is your answer? Okay, our P of 4 is equal to 2. Next, number 2. P of x is equal to x raised to 5 minus 3x squared minus 20. Our x is 2. What is your answer? Okay, our P of 2 is equal to 0. The number 3, we have P of x is equal to 2x cubed plus 3x squared minus x minus 79. Our x is equal to 9. And your answer is P of 9 is equal to 1,613. Now, for our activity number 2, show whether the second polynomial is a factor of the first. Number 1, P of x is equal to 3x cubed minus 8x squared plus 3x plus 2 divided by x minus 2. So, what is the answer? So, x minus 2 is a factor because the remainder is 0. Next, number 2. P of x is equal to 2x raised to 4 plus x cubed plus 2x plus 1 divided by x plus 1. Okay, what is the answer? So, x plus 1 is also a factor because the remainder is 0. And what about number 3? P of x is equal to x cubed plus 4x squared plus x minus 6 divided by x plus 3. The answer is x plus 3 is a factor because the remainder is 0. Activity number 3. Determine the value of k which is necessary to meet the given condition. So number 1, x minus 2 is a factor of 3x cubed minus x squared minus 11x plus k, when the remainder is 4. For number 2, x plus 3 is a factor of 2x raised to 5 plus 5x raised to 4 plus 3x cubed plus kx squared minus 14x plus 3 if the remainder is negative 27. And then number 3, x plus 1 is a factor of negative 4x raised to 4 plus kx cubed minus x squared plus kx plus 10 when the remainder is 25. Now let's get the answer. So for number 1, our k is equal to 6. For number 2, our k is equal to 10. And for number 3, our k is equal to negative 10. Thank you. I hope you have